Hey, welcome to the build show. We're inside the pool house there. We just took a quick shot from the house there. Come down and see it, and now I'm inside, right? So, as you can see here, it's a pretty spectacular space. It's what we call a volume ceiling, which means it doesn't have the flat ceiling. It actually follows the rafters in the volume. But the really cool aspect of this, I think, is these slope ceiling joists. Now, you put those in, it looks real simple. You say, hey, what's the magic there? But believe it or not, there's a lot of structural magic and ingenuity that went into that. When a structural engineer, he definitely had some fun doing that, because typically you have a ceiling joist that works in the horizontal plane, works as a belt, ties the roof together nice and simple. The minute I slope that and introduce it, then each of those ceiling joists don't just have a horizontal aspect. I've introduced a vertical aspect. We'll talk more about that when I jump down on the drafting table and what complexities that brought to the table. But the things that I wanted to point out here while we have the opportunity is, not only do we have those, they fall nicely inside the building, we have a nice series of lines, but as you know, I like to talk about architectural intent. So let's talk about that for a second. As you see these slope choices, they actually have intentional placement. This one falls directly on the center of the window. This one falls directly on the center of the window. This one falls directly on the center of the door. If I come over here, you'll notice that I have 4 windows here, but each of those windows falls directly on the center of that opening. So why do you do that, right? Well, obviously we do it to place some order, but as I spoke of before, I think the best thing or the best compliment that an architect can get is someone walking in the door and saying, oh my God, I love it. Place looks beautiful, but doesn't really know why. It just, that intent has a certain rhythmic order. That rhythmic order has very intentional placement. So we have the rhythm of the trusses, we have the rhythm of the windows, we have the rhythm of the doors here. And all 3 of those components are in concert with each other. So when I walk in the door and I take it all in, it just all simply makes sense, and it makes sense immediately. There's nothing that my brain really has to resolve. By having that kind of immediate response with 0 resolution required, it allows you to sit there and say, man, what a beautiful space. I love it. I'm very happy with the way this turned out. I'm working with Howell Custom Builders on this project. Brian, the super. I can't speak high enough of this guy. He is weeks ahead of every decision. The interior designer here, Christina Creston, has done a beautiful job. We're working as a really good team, making things look beautiful. Client's extremely happy, but who wouldn't be, right? It's turning out to be a beautiful little space. We're going to jump off to the drafting table. We'll talk about these slope ceiling joists a little bit more in depth, and we'll go from there. Hey everybody, welcome back to the design studio here. Got some great stuff here. Hope you enjoyed that little tour of the pool house. I think that thing's coming out pretty fantastic. Client is in love with it. I haven't walked anybody through it that hasn't fell in love with it. It's coming out really good. The big shout out to my buddy Brian, doing just an absolute fabulous job putting this stuff together. And the whole team at Howell Custom Building Group is just... It's an exceptional team and a true privilege to work with these guys. So let's talk about what we're doing inside there. We took a walk through. You remember I was standing here and walking that way where we were talking. And I was talking about design intent, layout, how all this stuff feels, sense of order. You can see here's the center line of those truss systems. You can see all the dashed lines there that basically outline the truss locations, and this one comes down through there. So you can see we basically have those 5 crossed ceiling joist trusses that we built out there on site. Remember we talked about the sense of order and how a sense of order leads to a very simple understanding that when I see it, it just makes sense, right? Everything kind of has its place, it falls in its place. And mostly, I don't question anything because it is so easily understood and so fundamental. I think, one of the hardest things that I tell people is being an architect, it's hard to be simple. Everybody around me wants to complicate things, and occasionally, even internally, we choose to complicate things. It is so hard to just be simple, but simple gets easily recognized. Easy recognition translates to easily understood. Easily understood translates to I love it, right? So that's how we get from here to there. All you young architects out there watching these videos, right? I had one of the things that sticks through me in my career is I had a design studio teacher that, we were doing a little desk crit, and I simply asked him a question, and his answer was, how the hell do I know? This is a monster you designed. He said, don't design monsters, and then you don't have these questions. So that conversation really stuck with me through time. So simplifying things as best I can and providing that sense of order really works really good for me. So anyways, let's get back to this. So we have those 5 truss lines. You can see that, this one's 5/0 and 5/8, 5/0 and 5/8, 4/11 and 3/8. So they're not exactly the same spacing, but there's no way that you can walk through here and really see the difference of 1 inch in placement in those. So I don't really worry about those. I worry about how does it relate to things that I see out there, right? So we talked about that earlier. Here's wall, little wall there. This is all wall, comes down to there, to there. So on this side, you'll see that truss is centered on that door. This truss is centered on that window. This truss is centered on that door. Over here, on the door that goes out to the covered patio, this truss is centered on that door. So there's a whole sense of order and intent on what's happening on that front elevation of the pool house. If we go to the back side, you'll see there's wall here, there's wall there, wall, 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 and there's 4 windows. Well, we have a truss here that just so happens to be the same distance away from the edge of the window there as this truss. This truss falls on the center of the wall between those 2 windows. This truss on the center of wall between those windows. Guess what? This truss falls on the center of the wall between the windows. And lastly, this truss here falls on the wall, and it falls at the same dimension there as the dimension of the windows to the truss there. So when I look through there and I walk through this space, I have this very, very good sense of order in that everything kind of has its position. The doors windows down the back doors here, and having those trusses align with them really set up this sense of rhythm in the space, so that when you see there, these trusses kind of march across the room, and it makes you feel good. Now, the second part of this is developing those trusses into this kind of sense of volume. And how do we do that? And how do we make that appealing? So now that we have the basic layout understood, let's just jump to section right quick. Here, you'll notice this is a building section, pretty fundamental one. If you watched my video on roof framing, you'd know that the minute you imply a load to the roof here, right, because this is on an angle, a couple things want to happen. There's a load that pushes out and one that comes down because of that angle. Well, what that wants to do really is take this wall, and it wants to take those rafters and have them fall and kick down. Well, we need to restrict that, right? We need to restrict this bending in the wall and the truss wanting to kick out and join it and this to fall. So how do we do that? Well, in the conventional framing method that we used in the house, we just simply put ceiling joists across here. But we wanted added volume in here and a little bit more architectural intrigue. I know some of these are buzzwords, but bear with me, they work. I have the little guy in here for scale. So get a sense of that. So what I wanted to do is, in working with the interior designer, and by the way,
We have Christina Creston on this project, and she's just doing a phenomenal job. And like the gents at Howell, she's just a superb teammate, and again, privileged to work with. So thank you, Christina, for giving me the privilege to work with you. That being said, we wanted to create even a little bit more volume. So rather than do something straight across, we figured we would do something sloped. So we have these two members that go up there, and you saw them in the video when we were out there, but they make a crossing pattern. Now, that just introduces another team player, and this team player, you know, he doesn't get enough credit, but John Cowan of Cowan Associates, he did all the structural engineering for me. And, you know, you sit there and say, oh, well, all he really did was he just took out this flat member and he did these two slope members. Well, the flat member works real easy. You apply a load, this wants to kick out, this just works like a belt and pulls it back in. It's pretty straightforward, very simple, like we talked about earlier. But even though I have the simplicity in layout, we complicated things by doing it sloped. So the minute this wants to kick out, yeah, this wants to tug on it, but then it tugs on this joint. Well, that joint pushes this member in compression, it pulls this one in tension, it pulls this one in tension, and it's not a flat horizontal load. These loads go up, these loads come down, this load comes down. Anytime you have a load on an angle, you have a horizontal component to that load or reaction, and you have a vertical reaction to that component because it's sloped. So by sloping things, we just made it exponentially more complicated for him. But John came through, like everybody on the team did, and he did his work. He did it impeccable, and he developed this truss design for us. We got that. We put it in place. I drew it up. Christina wrapped some beautiful light fixtures and some interior design on this, and then the gents at Howell Custom Build put it all together. But let's talk about those things a little bit more specifically, right? What did John do? So this is an elevation detail of the site-built trusses here. This is a little similar to the site-built trusses that we had out at the job site there. This one's just a little bit different in that it's not necessarily carrying a ridge beam here like our site-built trusses. And the site-built trusses is my last video. If you haven't seen that, I suggest you go back to that. You'll see there's a lot of things in construction that just tie back and forth. And while I do this little 14-minute video here on the interior of the pool house, I could elaborate this into an 8-hour video and probably still not stop talking. So, you know, we have to kind of cut to the chase, give you some bullet points, but there's things to be picked up in some of the other videos, so check those out. But basically, we have those slope ceiling joists. Those fall in between roof rafter members. You can see here, these are structural screws that get placed in there. Their number and their size gets called out. It's very specific because that's what they got designed to. So we have to use the Simpson SDS screws. We use 5 of them at a 0.2, I think this is 0.22 diameter on the screws there. And you can see we also have some solid blocking that's happening in between there. Up at the top, we have solid blocking. We have our ridge board, solid blocking there. But more importantly, we have this through bolt that goes through there. And, you know, we have some serious 3-inch plate washers there. But basically that through bolt pulls that ridge together. Because if we get that load, when this falls, this wants to split open also. So you have this force that we need to react to and solve for, but this also wants to tear open. So how do we keep that from tearing open? Well, we put these solid blocks in, and then we introduce this threaded bolt there to pull that all together to resist that forces of tearing open. But you can see, again, all that blocking, it's symmetrical. Yes, it complicated a couple things in that the wall height here is slightly higher than the wall height there. which means the ceiling joists actually rest on the top of the wall height there, but here you can see they actually come into the floor joist probably on the order of about 14 inches higher. So that complicates things because this isn't quite symmetrical with what's happening over there, so it complicated the engineering a little bit more. But like I said, when you work with good people find solutions, not excuses. And that's what we have here. We have a team of solution providers, and that's what makes a great team. But anyways, there you have it. That's how we took that little pool house. We have our 5 sloped ceiling joist trusses running through there. And that's how we provided that design intent, that sense of order, that good feeling that, hey, when you walk in, it just feels right. So until next time, look forward to seeing you on the Build Show again. And until then, long live our buildings.